Hi everyone. In this video we're going to test two different samples. First is aluminum and second is steel. So here we have them in different form. So I'm going to test them using this table for flat samples because Brinell hardness tester uses larger loads, so therefore it is unsafe to use this special concave sample holder for radial or cylindrical samples. So it can just slip and make some harm maybe, or we can damage the equipment with that. So therefore, with Brinell, we normally use flat samples. And first I'm selecting steel sample, and for that reason, first I'm going to go with 3,000 kilograms. So, and see how it behaves. Honestly, I'm not sure about the type of this sample, about the steel, what it is. I just took it from the bucket. So next time during our lab, we will cut our samples that we tested using tensile machine. So, but this time I'm just showing you how it works. And what we need to do first here is fix the indenter on the surface of a sample. So how we do that? We use this wheel and we run the sample against the indenter. And we do that until we hear the click here. So like this. So it means that we've applied some preload that positions the indenter properly on this sample that we have here. So the next step really is to apply the load, and to do so we just select some of the parameters here, like load duration time, so 12, 30 or 60 seconds. So we just can stick to 12 seconds and start indentation. Now it's going to dwell there for 12 seconds after the application of full load of 3,000 kilograms. And now the machine unloads the sample, moving the weights up. And this is the end of the test. So the next step will be go and use microscope or ocular and measure the indentation diameter. So we'll do that later. But for now, let's focus on our aluminum sample, so which will require much lower loading, and to do so, adjust the loads. I will need to remove some. So I'm just now having only 2 tons. Now I'm having 1.5 ton. And I'm going to remove more. Or, actually, since we have so big indenter, like 10 millimeters, so we should probably good to go with 1.5 tons. So we'll see. So let's stick to 1.5 ton with aluminum sample, and we do the exactly same thing. So we run the sample, the specimen against the indenter, and then we apply our preload until we click the wheel on place, and now we'll load the sample. Okay, this is it. So the sample is unloaded, and we can release the sample and see that our indentation has some diameter here. So we'll measure it and see if the results are adequate. And I can tell now, just by comparing these two samples, that the diameter of an indentation is approximately the same. So now you can see that actually, without any further measurement, that steel is much harder, because with the same diameter of indentation, steel has been loaded to 3 tons, and this we applied here with aluminum only 1.5 tons. So see you in the next video when we're going to measure our indentation diameter.